Welcome to Math on Ice, December 2018, Integral Equations, Part B and C. We will see one question from Part B and two questions from Part C. Totally three questions from this paper. The first question is, if phi is a function solution of the equation integral 0 to x 1 minus x squared plus t squared into phi of t dt is equal to x squared by 2, then phi of root 2 is equal to. This is a Volterra type integral equation. We are going to solve the problem by the Leibnitz rule. So integral 0 to x. The given question is 1 minus x squared plus t squared into phi of t into dt is equal to x squared by 2. Now differentiate both the sides. Using Leibniz rule, we will have this differentiation with respect to x partially, that is integral 0 to x. Partial differentiation of the term with respect to x will give us minus 2x into phi of t dt. And the differentiation of the upper limit is equal to 1. And then replacing t by x, we'll have it as 1 minus x squared plus x squared into phi of x, and as your lower limit is 0, you will get minus 0 eventually, so it is equal to differentiation of the right hand side is 2x divided by 2. 2 cancels each other, so this implies integral 0 to x minus 2x can be taken outside, right? So phi of t dt, which is equal to, and this way here minus x squared plus x squared cancels each other, only leftover thing is phi of x, which is equal to x. So here this implies integral 0 to x minus 2x phi of t dt is equal to x minus phi of x divided by minus 2x. So when I divide each numerator separately, it is x divided by minus 2x minus phi of x divided by minus 2x. So I have brought this minus 2x here. So this will not present here. So integral 0 to x phi of t dt is equal to x cancels, it is minus 1 by 2 plus phi of x divided by 2x. Right, now again differentiating the equation with respect to x. Here this term is independent of x, so it will become 0 and only the upper limit part will be there. Differentiation of x is 1 and this will be phi of x, which is equal to differentiation of minus 1 by 2 is 0, plus this is the differentiation of u by v rule. So we'll have 2x the whole square in the bottom and 2x as it is, phi dash of x minus a phi of x into differentiation of 2x is 2. So this is equal to phi of x is equal to 2 can be taken outside, x into phi dash of x minus phi of x divided by 4x squared. So 2 and 4 cancels each other, 2x squared. X into phi dash of x minus phi of x divided by 2x squared. So this implies phi of x. I'll take this 2x squared for each numerator separately. So phi of x is equal to x phi dash of x divided by 2x squared minus phi of x divided by 2x squared. I'll bring this minus phi of x divided by 2x squared to the left hand side. So this will be phi of x plus phi of x divided by 2x squared. And here it is equal to x and x squared cancels each other. So this is phi dash of x divided by 2x. That implies I can take phi of x outside, 1 plus 1 divided by 2x squared, which is equal to phi dash of x divided by 2x. Now bring this phi of x to the right hand side denominator and 2x to the left hand side numerator. So this implies 2x into 1 plus 1 divided by 2x squared, which is equal to phi dash of x divided by phi of x. Now this is equal to 2x plus, when you just divided by 2x squared, 2 cancels, 1x and another x cancels, that is equal to phi dash of x divided by phi of x. So this implies 2x plus 1 by x is equal to phi dash of x divided by phi of x. Now integrating both the sides with respect to dx, we'll have it as, in integrating 2x, I'll have it as 2x squared by 2. And integration of 1 by x is log x plus log x is equal to integration of this part. Denominator is phi of x and numerator is phi dash of x. So it is log of phi of x. Right. So this is your solution. Now 2 cancels each other. Log x plus x squared is equal to log phi of x. Now we have this phi of x, which is rising to the power e on both the sides. We will have it as e to the power log x plus x squared is equal to e to the power log of phi of x. So here it is e to the power log x into e to the power x squared, which is equal to e to the power log into phi of x. Log and e cancels each other. Log and e cancels each other. We'll have it as this phi of x is equal to x into e to the power x squared. Now they have asked the question for phi of root 2. So phi of root 2 will be root 2 into e to the power root 2 the whole square. So that is root 2 into e to the power 2. So the correct answer is phi of root 2 is equal to root 2 e power 2. Root 2 e power 2. So second option is the correct option. Moving on to the next question. A characteristic number and the corresponding eigenfunction of the homogeneous Fredholm integral equation with kernel is given. Okay, they have taken a Fredholm integral equation of homogeneous condition. So the given question will be y of x is equal to lambda times of integral. Your limit is varying from 0 to 1. K of x comma t into y of t dt, right? So this is y of x is equal to, they have given k of x comma t that is varying between 0 to x and x to t. But the given question is varying for x variable, but we have to convert this k of x comma t for the variable t. So here y of x is equal to lambda times of integral 0 to 1. I need to change this one, right? So I'm going to vary this one from 0 to x and then lambda times of integral x to 1. What is the k of x comma t here? Given in the question x into t minus 1, t into x minus 1. That is for x variable. Now I'm going to replace x by t and t by x. So here for the interval 0 less than or equal to t less than or equal to x, I'll have it as t into x minus 1. And for the interval x less than or equal to t less than or equal to 1, I'll have it as x into t minus 1. So for 0 to x, the kernel will be t into x minus 1 into phi y of t dt, and this one lambda integral x to 1 x into t minus 1 into y of t dt. Y of 0 will be equal to, when I apply y of 0 here, this integral will vanish because the lower limit is 0 and upper limit will become 0. And here lambda times of integral 0 to 1, if I put x is equal to 0, this term also vanishes. So I'll have y of 0 is equal to 0. And what about y of 1? If I put y of 1, in the place of x, I should substitute 1. Integral 0 to 1. This integral vanishes as 1 to 1 vanishes. Limit is from 1 to 1. So here integral 0 to 1, if I substitute x is equal to 1, this integrand will become 0. So therefore y of 1 is also 0. Right. So these are all the conditions, and also phi of x is equal to lambda times of integral 0 to x. This can be solved by using Leibnitz rule. Y dash of x is equal to lambda outside integral 0 to x. Differentiation of this part will give us t into y of t dt, plus if I put in the place of t x, I'll have it as x into x minus 1 into y of x, and your lower limit is 0. So here you will have the lower limit part to be 0, and then plus lambda is outside integral x to 1. Differentiation of this one will be t minus 1 into y of t dt, and then the upper limit is 1, therefore it is a constant. Differentiation will give you eventually 0, so only the lower limit part, minus x into x minus 1 into y of x. Now these two terms cancels each other. So here y dash of x is equal to lambda outside integral 0 to x t into y of t dt plus integral x to 1 t minus 1 into y of t dt. Now again differentiating with respect to x, y double dash of x is equal to lambda times of differentiation of this part is 0 because it is independent of x, and also we have x into y of x, and this way here minus of the, because lower limit has x, so we will have the lower limit part alone, minus of x minus 1 into y of x. So y double dash of x is equal to lambda x y of x minus, we'll have lambda x y of x, x y of x, and then plus lambda y of x. So these two terms cancels each other, or else you can keep this lambda outside itself and x y of x minus x y of x cancels inside itself. Y double dash of x is equal to lambda y of x. So we got the equation to be y double dash of x minus lambda into y of x is equal to 0. So this is of the ordinary differential equation type. So I'll have this auxiliary equation for this equation as m squared minus lambda is equal to 0. So here what is the question they have asked? A characteristic number and the corresponding eigenfunction of the homogeneous Fredholm integral equation, and every lambda given in the option or in terms of pi. So here I'm going to go with the imaginary roots. If you take the equal roots, if you put lambda is equal to 0, you'll have m is equal to 0, 0. If you take lambda greater than 0, a positive value, you'll bring this term to the right hand side, then you will have e to the power lambda, e to the power minus lambda, there the root lambda, and e to the power minus root lambda. There the answers. So in those two cases, you will find the trivial solution only. As the options are with respect to pi, I'm directly solving with the imaginary root problem. So lambda is equal to, I'm going to take minus mu squared. So I'll have m squared plus mu squared is equal to 0. M squared is equal to minus mu squared. So m is equal to plus or minus I mu is my solution. So I'll have the y of x is equal to a e to the power, sorry, a cos mu x plus b sin mu x. Now, as we know the conditions, y of 0 is equal to 0 and y of 1 is equal to 0. Y of 0 is equal to 0 and y of 1 is equal to 0. I'm going to use this here. Y of 0 is equal to a cos 0 and then a cos 0 plus b sin 0. So I'll have it as b sin 0 fully 0. A cos 0 is 1. So I'll have a alone. A is equal to 0. Next is y of 1 is equal to 0. If I substitute 1 here, y of 1 is equal to 0. A cos mu plus b sin mu. As we know, a is equal to 0. This part will vanish. So only leftover thing is b sin mu, which is equal to 0. So sin mu is equal to 0 means mu should be n pi, right? Mu should be n pi. Therefore, lambda, as lambda is equal to minus mu squared. So that implies minus of n squared pi squared. Lambda can take n squared pi squared, where n is any integer value. So here n squared means n will always have a positive n, even though it is positive or negative, n squared is going to be a positive value. So the lambda will be of the type minus pi squared, comma minus 4 pi squared, comma minus 9 pi squared, comma minus 16 pi squared. These are the characteristic numbers, right? The eigenvalues. Now we will see what are the options present here. Here the present options are lambda is equal to minus pi squared, lambda is equal to minus 4 pi squared. Lambda is equal to minus 2 pi squared can never be the characteristic number eigenvalue. So this is false, this is false. We need to verify for only these two, A and C. So when I verify for minus pi squared, phi of x is equal to sine pi x. We must arrive at phi of x is equal to the corresponding eigenfunction should be sine pi x. Let us verify whether we are getting sine pi x or not. The first option, lambda is equal to minus pi squared. So from this we get mu is equal to pi, because we'll have n is equal to 1, so mu is equal to pi. The corresponding eigenfunction will be equal to y of x is equal to, we'll have a to be 0, right? So this term vanishes, only the sine term remains the same. So b as it is. It can be any arbitrary constant. Sine mu x, sine pi x. So this is the corresponding eigenfunction. Sine pi x is the corresponding eigenfunction. Yes, it is given correctly. So the first option is true. Next, lambda is equal to minus 4 pi squared. Phi of x is equal to sine 2 pi x. Lambda is equal to minus 4 pi squared. And then we have to verify sine 2 pi x or not. So what about n here? N is equal to 2. So I'll have mu is equal to 2 pi. So y of x is equal to b sine 2 pi x. The correct option is option D also. Fourth option is also true. The next problem, if phi of x is a solution of phi of x is equal to given a function. So we have phi of x is equal to 1 minus 2x minus 4x squared plus integral 0 to x 3 plus 6 times of x minus t minus 4 times of x minus t the whole squared into phi of t dt. We need to find phi of log 2. Take a differentiation by using Leibnitz rule. This is minus 2 minus 8x plus integral 0 to x. Differentiation of 3 is 0. Differentiation of 6 into x minus t is 6 simply. And this way here it is minus 8 into x minus t. The whole thing into phi of t dt. The upper part is plus, your upper part will give us integral 0 to x. The upper part will be 3 plus 6 into x minus 4 into x minus x the whole squared, everything into phi of x. And the lower part is actually limit is 0, so you'll have minus 0 simply. So phi dash of x is equal to minus 2 minus 8x plus integral 0 to x 6 minus 8 into x minus t the whole thing into phi of t dt. And this is x minus x 0, x minus x 0, only 3 into phi of t will be left, so plus 3 into phi of x, 3 into phi of x. And the next step is again take the differentiation using Leibniz rule. So this is phi double dash of x is equal to minus 8 plus integral 0 to x. Take the differentiation here, minus 8 into phi of t dt. And then the upper limit part, which will be plus 6 minus 8 into x minus x into phi of x. And the differentiation of 3 into phi of x is 3 into phi dash of x. So phi double dash of x is equal to minus 8 plus integral 0 to x minus 8 into phi of t dt. This one x minus x cancels each other, so we will have a plus 6 into phi of x plus 3 into phi dash of x. And then we have phi triple dash of x, that is equal to 8 will become 0, as 8 is a minus 8 is a constant, so this will become 0 plus this part is independent of x term, so this will also become 0, only the upper part, that is substitute here minus 8 into phi of x plus 6 into phi dash of x. Then we will have plus 3 into phi double dash of x. So the given question has been turned to uh, third order differential equation. So this is phi triple dash of x minus 3 into phi double dash of x minus 6 into phi dash of x plus 8 into phi of x is equal to 0. When you write the auxiliary equation, you will have it as m cube minus 3m squared minus 6m plus 8 is equal to 0. This is a cubic polynomial, so I'm going to solve the cubic polynomial 1 minus 3 minus 6 and 8 here. So 0 1, I'll take minus 2, minus 2 into 1 is minus 2, this is addition, minus 5, 5 2s are 10, so I'll have 10, this is 4 here, minus 8, this one 0. So I'll have x is equal to, that is m is equal to minus 2, m is equal to minus 2 as a solution, and m squared minus 5m plus 4 is equal to 0. If I multiply, I should get 4. If I add, I should get minus 5. 4 and 1, negative, negative. So I'll have m is equal to 1, comma m is equal to 4, comma m is equal to minus 2. So the solution will be phi of x is equal to a e to the power x plus b e to the power 4x plus c e to the power minus 2x. Now what is asked in the question? We need to find phi of log x. Okay, when you look here, so we need this a, b, c and all. For that, we will just take this condition, phi of x. What is phi of 0? Phi of 0 is equal to, here this integral part will vanish, 0 to 0, 0. Here 0, here 0. So phi of 0 is 1. What about phi dash of 0? Phi dash of 0 is here. Phi dash of 0, which will be this full part is equal to 0. Minus 2 will be there. And then plus 3 times of phi of 0. Phi of 0 already 1. So minus 2 plus 3. So this is equal to 1. So we'll have this phi dash of 0 is equal to 1. And also we have one more variable c. So for that we will find from phi triple dash of x is equal to, we got it as minus 8 into phi of x plus 6 into phi. Okay, so that we will find from phi double dash of x. Phi double dash of x is here. Phi double dash of x is equal to this, in this equation I'll find phi double dash of 0 is equal to minus 8 here, and this way this full part is equal to 0. 6 plus 3 is 9, because phi of 0 is 1. Phi dash of 0 is also 1. So this one will be 6 plus 3 is 9. So plus 9. So this is also equal to 1. So we got phi of 0, phi dash of 0, phi double dash of 0 all equal to 1. Phi of 0 is equal to 1. Phi dash of 0 is equal to 1. phi double dash of 0 is equal to 1. So for this, we have to find phi dash of x and phi double dash of x and all. What is phi dash of x? Is equal to a e to the power x plus 4b e to the power 4x and then minus 2c e to the power minus 2x. And phi double dash of x is equal to a e to the power x plus 16b e to the power 4x plus 4c e to the power minus 2x. Now I am going to solve the problem by matrix method. I have a, b, c as constants, 3 equations and 3 unknowns. So here one, I have e power x, e power 4x, e power minus 2x. Let me take it as x, y, z. And a, b, c here. If I substitute, let me substitute and then take it into the matrix form. Phi of 0. So I have phi of 0 which is equal to a into e to the power 0 is 1. And then here e power 0 is 1. Here e power 0 is 1. So I'll have a plus b plus c is equal to 1. And then phi dash of 0 which is equal to a plus 4b minus 2c is equal to 1. And then phi double dash of 0 is equal to a plus 16b plus 4c is equal to 1. Now I will take it in matrix form. This is 1, 1, 1, 1, 4 minus 2, 1, 16 and 4. Everything into A, B, C is going to give us 1, 1, 1. We need to find A, B, C, right? Now I'll make these two as 0. So 1, 1, 1, 0, 0, 4 minus 1 is 3, minus 2 minus 1 is minus 3, and 16 minus this one, 16 minus 1 is 15, 4 minus 1 is 3. Right, I have made this part 0. I'll have this augmented matrix also. So I'll have this one 1 and I have subtracted. So this part is equal to 0. So next I will use these two equations. So this is similar to 1, 1, 1. Okay, let me take, this is my thing. So I'll have it as 1, 1, 1, 0, 3 minus 3, 0, 15, 3. And then with the ABC, A, B, C, which is equal to 1, 0, 0. So here for the first row, when I operate, I'll have A plus B plus C is equal to 1. Second row operation will give me 3B minus 3C is equal to 0. I'll have B is equal to C. And from the third row, I'll have 15 B plus 3C is equal to 0. As B is equal to C, I'll have 15 C plus 3C is equal to 0. I'll have C is equal to 0. C 0 means that implies B is equal to 0. If B is equal to 0, A, B is equal to 0. In the first equation, when I solve, I'll get A is equal to 1. So y of x will be, that is phi of x here. Phi of x will be only a is equal to 1, only e power x. So I have got phi of x is equal to e to the power x. Now what is the question? They have asked us to find phi of log 2. So when I substitute phi of log 2 which is equal to e to the power log 2, e and log cancels, I'll have the answer as 2. The correct answer is 2 and it is present in the first option. That's it. Thank you.